Hi. After one of my recent videos, got a really cool question from one of you. It's about making plasma in space, or making arcs, thermal arcs in space. So hello, my name is Greg Friedman. Welcome to the channel. Here I like to chat about science with heavy focus on plasmas because that is my technical area of expertise. So let's look at the question. Using thermal plasma to melt lunar regolith is something fantastic, but can we produce thermal plasma in space? And what is magnetic rotating plasma, and how you can control plasma with magnetic field? Awesome. That's two questions, but they're very, very, very related. So on Earth, you go to Home Depot, you buy a welding torch, maybe a TIG or MIG or stick, but what happens is you ignite plasma in air, and this thermal arc is used to melt your metal for welding. How do you do that in space? What's the problem? Well, there is no gas. It's vacuum. So you need to somehow get the gas. What you can do, and I'm not going to give away all my secrets, but in general, what you can do, you can bring a little bit of gas with you, use that gas. Once you introduce it between the electrodes, it's vacuum, so that gas will quickly escape. So you need to add the gas, quickly ignite the arc, and then you can melt whatever it is that's on the other side of your arc, and you can use that molten rock to as the medium for plasma. So that's going to off gas. It gets pretty tricky, so our regolith melting chamber is not a very straightforward one, but it's doable. It's doable. You know, arc welding in space, creating arcs and sustaining arcs for purpose of metal manufacturing, metal jointing in space is very different. Your shielding gas, which is on Earth argon is heavy, it kind of sticks around where you put it. But in space, it quickly escapes into the outer space. Also, molten metal in microgravity behaves quite differently. There's no gravity, right? So this liquid thing will flow God knows where. And also off-gassing. So those of you that know welding know that there are a lot of things trapped in the metal. Perhaps some residual oils or residual gas. There's stuff that bubbles up, and all of that in space is very different behavior than on Earth. So first question was, can it be done? Yes, you can have thermal plasma in space, but it is different than making it on Earth. It has maybe, it's different. Maybe some advantages, definitely lots of challenges there. Now, how you can control it with magnetic field. Arc, plasma arc, is flowing electrons. Flowing electrons have their own magnetic field. So if you put them in a static or not static, if you put them in a magnetic field, you can actually control the behavior of the arc. You can rotate it, you can spin it in really interesting ways. So we very frequently use this phenomena, and this is often called gliding arc plasmas, because you glide the arc on the surface of the electrode, and there's really cool stuff, like you can trap this arc using clever combination of magnetic fields, maybe with some gas dynamics. You can create really cool flows, increasing volume of plasma. We use this to enhance catalytic effects of plasma in plasma chemistry. But anyway, you know, short answer, can you make arcs in space? Yep. But your Home Depot welder probably isn't going to work. Well, it's definitely not going to work the same. And it's probably not going to work at all you will have to do some heavy modification. Now you can weld inside of the spacecraft because there is air. That's the same as Earth, but you're still in microgravity, so your molten metal will behave very differently, maybe fly around all over the place, and needs to be carefully considered. Anyway, thank you for your question. If any of you have any plasma-related questions, please post them in the comments down below. And if I made any mistakes, please also post them in the comments. I love learning and I do it every day. Thanks, guys. See you in the next one.